Bismillahirrahmanirrahim. Today we will talk about vector and scalar. Vector and scalar quantities. Actually, physical quantities can be divided into two types according to their definition, or by how can we define this physical quantity. So if we need to define this physical quantity by magnitude only, then this physical quantity is a scalar quantity. But if we need magnitude or number or a value plus the direction, then this physical quantity is called a vector quantity. Examples for this. For the scalar one, the distance. The distance from A to B here is 3 kilometers, for example. And then from B to C is 1 kilometer. So the total distance here is 3 plus 1, so it will be 4 kilometers. Okay. Here just we write the number because distance is scalar. But for displacement is the distance between the starting point and the end point with direction. This is the displacement. The length between the starting point till the end point with the direction from the beginning till the end. So it will be 4 kilometers to the right. From A to C to the right. Another example about distance and displacement. If you go from here to here, the distance is only 5 meters. Okay. Another example about distance. If we go from the green point till yellow, then from yellow we go to the red. So the distance from green to yellow is 5 meters. Plus the distance from yellow to red is 3. So total is 8, as it's written here, 8 meters. Okay. For displacement, from A here to B, the distance is 5 meters to the right. Okay. From the beginning to the end. Here we go also, the journey was like this, from the green to the yellow and from yellow to the red. So the distance we said it was, or it's 8, but here no, it's not 8. It will be, what is the starting point is the green, what is the ending point is the red. So what the distance or the length between green and red is, for example, 2 meters and to the right. I don't care about this part. The displacement, I told you that is the length between the starting point till the end point. I hope you understand the difference between these two, distance and displacement. Now, second example about the scalar and vector, speed and velocity. What is the speed? We know that the speed is equal the distance over the time. Okay. If this car is moving this distance on this duration or this unit time, so its speed is equal the distance over the time. For example, the faster car can go longer distance over the same unit of time. If this first car goes 5 kilometers, for example, in 10 minutes, then this car is faster if it goes 10 kilometers per 10 minutes. It is faster. Or the faster also can be if this car can go, for example, less or the same distance, 10 kilometers in less time, less than 10, it's maybe 5 or whatever the number. So less time by the same distance. Okay, this is the speed. So speed only magnitude. Velocity is also distance over time, but plus direction. also value plus direction. This car, for example, goes or has a velocity 25 meters per second toward the north. I just write the direction, so that's why I wrote the velocity. But if I wrote 25 meters per second, this is only the speed, nothing else. Okay? So the direction is the main significant thing for the scalar quantity. Okay, I want to just give you some example about scalar and some examples, more examples for the vector. For the scalar, we have also temperature, we have work, we have time, we have volume. Here we have for vector, we have force, moment, momentum, acceleration. I just told you from 2 minutes ago, direction is very important thing in the vector because it can be negative. The vector quantity can be negative value because direction has an effect in the calculations. How that can be? For example, or let me just leave this part till I talk about the force down here in this video also. So just now, till now, just should know that it can be negative, but for that scalar, it will be never negative. I cannot find negative temperature or work or time or volume. I cannot find this value. Okay. The main important example to explain the difference between vector and scalar here is the displacement or the velocity for a car moving in a circular motion. Okay, as you see, the car just starts from this point here, which is A, and goes around this circular track and finish at the same point A. So what is I want to find the velocity. I just said velocity is the displacement over time or distance over time plus the direction. The same are correct. So if the displacement, what is the displacement here? I start from the same point and finish at the same point. I told you displacement is from the beginning till the end. So there is no beginning, there is no end. We have only one point. So displacement is 0. That means if this value is 0, if this value of displacement is 0 over the time, that means velocity also is equal to 0. So here the velocity is 0. But here when I want to find the speed, the perimeter of this circle, or the distance from here till here, for example, it's 20 meters or whatever, or 50 meters as the example. So 50 here, no, it's 1000 meters or 100 meters. 100 meters over the 20 seconds time which that car takes. Then the answer will be 50, or 1000 meters. So the answer will be 50 meter per second. Okay, this is the speed. Okay, I have a value here, only value, but no direction. The direction here just affected has an effect in my calculation, so that's why I got different answer. Okay. Okay. Let me go to the next topic or next point, which is now force is also, we said forces is one of the vector quantities. Okay, I want to show you that how can I have a negative value. Okay, for example, if I have a box, this man, for example, pushed this box by 10 Newton. Okay, and 10 Newton toward the left. and because the force goes to the left, so it has a negative sign. And another man stand here and push this box with 2 Newton, okay, and because that force is to the right, so it has positive sign, okay. So what is the net force, the resultant force, the overall force, okay? The net force will be equal minus 10 plus 2, which will be equal minus 8 Newton. So this is the force. This box will move toward the left side by 8 Newton. This is how can the vector quantity be negative, because the direction affected on the, or has an effect on the calculation, okay. As you see here, if F1 equal to F2, if this is force here and in opposite direction, the net will be negative, because this is to the right side is positive, this is to the left side is negative. So for example, 5 minus 5 is 0. So no acceleration, no motion here. It will be stopped as it is. Here in this part, also here, this is the same thing like this one, okay. But here F2 is bigger than F1, okay, and so for sure I will have a net force toward the right, and it will be positive. As you see, the length of the, as long as F2 is bigger, the length of the arrow is bigger also than F1. So the length of the arrow shows magnitude and its head points to the direction. I have to know about this, because sometimes in the past paper give you a ball, for example, and ask you to write the forces which is acting in this ball, and the ball has experienced a free fall, for example. It's just so you will write this is the weight is the one. And if he give you the weight, for example, is 15 Newton and the resistance is 2, so you will write small arrow which is 2 Newton and the weight is longer, make it longer, and 15 Newton. So the length here has a meaning, okay? So before I go to this one, I want to show you, or to be sure about one point, which is the action of the forces, or any like velocity or any vector quantity. If the vector quantity goes up, that will be positive side, positive value. If it goes down, it will be negative. It will go, if the vector goes to the right, it will be positive. Left, it will be negative. Here they are like x and y axis. This part of x is positive, this part is negative, this part of y is positive, this part of y is negative. The same like x and y axis. Okay? Next point is about the average speed. From where we find this? Average speed or average velocity. When do we need to find the average speed and average velocity? For sure, if the car starts from the 0 or point A at the beginning and finish to the point B, between A and B, for sure it will never have the same speed. When your father starts to drive the car, he starts with initial velocity, and by the time his speed increases, right? To at the end reach to the V, final speed. So if I want to know the speed which is between U and V, which can be, which I can say this is the speed for the whole journey, I have to find something which is called average speed, which is average speed is total distance over total time. Okay, and this is a general case. In all the cases, to find the average speed, I have to find total distance over total time. And why I have to do this? Because speed usually vary throughout a journey. For this reason, we often calculate the average speed of an object. Okay? Average velocity is the same thing, it's not a big difference about the average speed. I will find the displacement divided by the time. Okay? Okay, there is a special case from the average speed, which is if the journey is uniform, that means it has a constant acceleration or deceleration. I can calculate the average speed by using this formula, which is the initial speed plus the final speed over 2. If I have what? If I have a constant acceleration or deceleration, that means the acceleration doesn't change, constant. Okay? So if I have only 2 speeds, initial and final, then I can just add them and divide them by 2. Okay? I know that about the average speeds, the speed in average or velocity or average velocity they have, or speed only, they have the same unit, which is meter per second as the international units, because from where I got this? From the formula, distance over time meter per second. From the formula I can find always the units. Okay, so what about the acceleration? What is the acceleration? If the speed of the car changed during a period of time, then that means this car accelerates. Acceleration is the rate of the change of the velocity. So velocity change during a period of time. This rate means during a period of time. Okay, so as you see here, the change of velocity, so the final minus the initial, there is a change. Or I can write by Latin, this is delta, it means change. Delta V means change of velocity over the t. This correct, this correct. This delta V, it means V minus U, the change of the velocity. Okay, over the time. So if I change the velocity by unit time, then I have acceleration. So accelerations, that means this car speeds up, right? Goes faster. Deceleration means this car slows down or starts to decrease its velocity. I can say deceleration is also equal the negative of the acceleration. In the past paper, in the theory, paper 4, if they give you acceleration and then write here, and in this case it was deceleration. Okay, so I will write minus the value, meter per second square. Okay, and if he write deceleration, no need to write minus, no need to write minus at all, just write the value, because he told you it's deceleration. So if you write minus, that will be wrong, because minus means this is acceleration. No. Okay, so just if he asked you to write acceleration and the case was deceleration, then write minus, and if he write deceleration, just write the value without negative this negative sign. The unit of the acceleration is meter per second square. Okay, because here I told you acceleration is equal to change of velocity over the time. What is this? The unit of the velocity, it's meter per second. What is the unit of the time? It's second. So I have here 2 seconds, which is meter per second square. Okay, difference of decreasing acceleration, and the difference here, we have a difference between these two terms, decelerating acceleration and deceleration. We know that deceleration means slow down when the speed is decreasing, that we have deceleration. But decreasing acceleration, if the acceleration decreases, that means still the speed is increasing. In this case, where we can find it in the free fall. In the free fall, the acceleration decreases, but still the speed increases because I'm going down. Okay? So check this video about the free fall to understand how this can be happened. Okay? Thank you for today, and I hope you understand what I have told you.